Hey folks, last topic of Unit 3. Another one, like I said, last section. Usually kids enjoy this one. It's pretty straightforward. So just straight up solving. So you're trying to get x by itself, same thing we did back in Algebra 1. So if I'm looking at example 1, who's farthest away from x on the same side? That would be 6. So I'm going to bump that to the other side. I would have 3 log of x equals negative 2. Who's farthest away from x on the same side now is 3, connected by mult, so we would divide. And we finally get to something that's worthy of our mathematical skills, and that's how to get rid of log. So remember, log cancels out with to the. So if you have a specific log base, it's going to cancel out with a specific to the. So let's do a quick review up at the top. 2 to the x versus log base 2 of x. So if I want to kill 2 to the, I kill that with log base 2. If I want to kill log base 2, I kill that with 2 to the. So it's kind of weird. We're going to take that log and we're going to put it up in the exponent. So coming back to our example here, I want to cancel out log. Well, wait, log is really what base? Log base 10. So 10 to the is what I'm going to do to both sides to kill off log. So 10 to the is the first time we've ever done this, but we're taking the whole side of the equation and we're putting it up in the exponent of a base. So 10 to the log cancels out, and we're left with x equals 10 to the negative 2/3. 10 to the negative 2/3 is something that I can calculate. And we get, oh, what did I do wrong? Oh, nothing, just round. So x is approximately 0.22, right? I would round that 1 up to a 5. That 1 up to a 2 because of the 5. All right, you probably got the basics. If you want to try example 2 on your own, I would encourage it. If you need a little bit more help, let's do it together. So who's farthest away from x on the same side is the 5. So I would divide by the 5 first. Log base 4 of 6x equals 18 over 5. I'm sure that's some nice decimal, but I'm just going to leave it as 18 over 5 now. I'm going to type this in all in the calc all at once. All right, now who's keeping log base 4 from being by himself? Sorry, who's keeping x from being by himself? The 6 and the log base 4. The log base 4 is farther away, so what kills log base 4? 4 to the. 4 to the. So I have now 6x equals 4 to the 18 over 5. Now from here, I can do the rest of this on my calc because I can do this on my calculator and I know I got to still kill off that 6 that's connected by mult. I'll just kill it with division. So 4 to the 18 over 5. 4 to the 18 over 5. Take that answer, divide it by 6, and we figure out that x is approximately 24.5 would be fine if you just wanted to write the 5. 5.1 is, I like to go to 2 decimal places. AP Calculus goes to 3 decimal places and they truncate. So their answer would be 24.505. They just chop off after 3 decimal places. In my class, I prefer 2 decimal places and I expect you to round properly. When you take AP, different story. All right, so this is kind of the heart of the idea. The heart of the meat of the lesson is how to kill off logs. And we just kill it by whatever the base is to the. So what kills log? 4 to the. Looking at example 3. So what's the messiest thing on the left-hand side? Log base 6. What's the messiest thing on the right-hand side? Log base 6. So what we can do is we can just kill that off right away. So I'm going to the right off the bat. So what kills log base 6 is 6 to the. Yeah, well. 6 to the, and 6 to the. Now that those are gone, we can look at what's still left over, and that leaves us with 9x squared subtract 5x equals 3x squared plus 4. All right, so I'm happy that I don't have any of those logs anymore, but I'm not happy that I've got all these x's, especially since one of the x's is x squared and the other x is just an x, which means I can never get those two combined. So anytime you have an x and an x squared, I hope your math voice is screaming the same thing mine is, and that's to factor. And so before I can factor, I've got to get everything to the same side. So I'm going to subtract this over. 9 take away 3x squared is 6x squared. Subtract 5x, and then I'm going to subtract over the 4 equals 0. My math voice is screaming factor here. Hopefully yours is as well. So remember how this works. First thing times last thing is negative 24. Negative 5. What works? 2 and 12, 3 and 8. 3 and 8. I need a 3 and a negative 8 to make a negative 5. So 6 doesn't make 3 or 8, so it's got to be 2 and 3. The 2 can make the 8, so I'll make that a negative 4. The 3 can make the 3, so I'll make that a positive 1. Then we would ZPP. Keep an x from being by himself. ZPP. We would get x equals negative 1/2, or x equals 4/3. Let's have you try example 4 on your own. Example 4 is kind of nice. I mean, I've still got the to this, so I'm going to 3 to the and 3 to the. I've got the log, so I can, it's lucky there's one log on either side, so we can just cancel them out. We get 3x plus 12 equals 6 minus x. I like this one a lot better than the previous one because there's multiple x's, but they're the same kind of x, so I can join them together. I'm going to bump this x across, so that's a minus x gets added, be 4x. Subtract the 12, that's farthest away. Divide by 4. 6/4, you can either turn that into a decimal or turn it into a reduced fraction. You must clean it up, though. 6/4 would not be okay to leave in this class. I'm going to leave it as a fraction. Maybe you did negative 1.5. That's fine. Either way works. All right, so here's the tough ones. And these are the ones, I'll be honest, these are the ones that I'm going to give you when it comes to the test. If you can solve these, you could have solved any of the ones up before it. So this is the scenario where we have multiple logs on the same side. So up here, we had multiple logs, but there are just one on each side, so we could cancel them out. Here, I've got 2 logs over here and only 1 log over here. Even if there were 2 logs over here, because it's adding, I can't cancel them with e to the. So it's kind of tempting to write e to the, e to the, e to the. It's not legal. So what I'm going to do instead is I'm going to condense. Remember a couple of notes ago, a couple sections where we did expand and condense? So these 2 natural logs have an add in between them, which means I can condense them into 1 natural log with a multiply in between them. And this has a coefficient of 2. Remember that move that we could take that and we can bump it up to the exponent. Now you'll see that I've got a natural log on either side, which I can then kill off. But I want to point out again, I couldn't do that right off the bat because I had too many natural logs on the same side, and I had something in front of this natural log. So I had to do some moving around before I could get it in a spot where I could natural log. Now that we've got it in that spot, let's go ahead and try to kill off the natural logs with an e to the and an e to the. Now I know I'm going to have to clean this up anyway, so I might as well do it at this stage. This is now gone in my head. It's gone. So I'm just going to now start to distribute this. So that would be what? 2x squared, subtract 3x, subtract 4x, plus 6 equals x squared. Combine like terms, 2x squared minus 7x plus 6 equals x squared. I wish I would have subtracted that over in the same move, but I didn't, so I'm going to run out of room probably. So I'm going to subtract now. Before I can factor, I always have to get my equation equal to 0 so we can ZPP it. And we get x squared, subtract 7x plus 6 equals 0. Now we can factor this. So 1 times 6 is 6 with a negative 7. So that's a minus 6 and a minus 1. So this factors into x minus 6 times x minus 1 equals 0, which we then ZPP, and we get x equals 6 and x equals 1. But do not box these in so fast. So this is one of the first times in mathematics that I said, what is going on? I couldn't believe it. We did all legal math moves from here. But because of if you remember the graph of natural log, the graph of natural log looks something like, just a quick little sketch, looks something like this. Natural log does not live anywhere that there's a negative x. So even if we do legal mathematical moves, sometimes we can create a solution that is not actually a legal solution. So let's take 6 and plug it back in. What's 6 minus? So we can't natural log a non-positive. There are 3 bad things, 3 problems in math. 2 of them you should know definitely by heart. You cannot divide by 0. You cannot square root a negative. Those are the big 2. Now we can add to the list, you cannot log a non-positive because the graph of log is only on the positive side. So that means you can't do log of 0 and you can't do log of any negatives. I'll prove it real quick. What's the log of 2? Some number. What's the log of 0? Can't do it. What's the log of negative 2? Can't do it. That's an imaginary. Here's the I at the end. I just have my calculator in imaginary mode. So you cannot, there are no real solutions to logging non-positives. So let's see if we created a non-positive. So let's take 6 and plug it back in. What's 6 subtract 2? 4. 2 times 6 is 12. Take away 3 is 12. Take away 3 is 9. Sorry, that took so long, but 9's positive, and then 6 itself is positive when I put it in there. So 6 was fine. 6 didn't create any non-positives. Now, when I put 1 in here, what's 1 take away 2? Boom. If this doesn't work in any piece of the original, notice I didn't put it into any of the part I wrote down. I put it into the original. If it doesn't work in the original, it creates something that we call an extraneous solution. It was a solution. We did all legal math moves, but it created an answer that actually doesn't work in the original equation. Kind of weird. All right, let's have you finish up here. Pause if you haven't yet. Try to do the last one. Okay, let's see. So I'm first going to get those logs together. So that would become their log of plus. So that's going to be log of the quantity x times the quantity x subtract 9. So this is a little bit different. There's only one log over here where these other ones had logs on both sides. But that's okay, though. We can still kill off that log. I mean, there's only one log over here, so what would undo log? 10 to the. Now, the price is you got to do 10 to the on the other side. Now, on these, those just undid each other. This is going to create a new number, which is okay. I'm going to distribute this time, save myself a little bit a step. So that's going to become x squared, subtract 9x. 10 to the first is 10. If you've got an x and an x squared, the only way to solve that is by factoring. So I'm going to set it up equal to 0. Now I'm going to factor 10. That makes 9 is minus 10 plus 1. ZPP, I get x equals 10. I get x equals negative 1. Now I'm going to go back before I box anything in and see if I created an extraneous solution. So let's put 10 in there. 10 goes in for x. That's 10. 10 is positive. 10 take away 9. 10 take away 9 is 1. That's positive. So that one's good to go. Negative 1, right away it's over. Negative 1, log of negative 1 is negative, plus negative 1 minus 9 is negative 10. So this created an extraneous solution. I'm okay if you just write EXTSOLN. Now notice, extraneous solutions can be positive or negative. Just because you get a negative answer doesn't mean it's automatically extraneous. It could or could not be extraneous. It depends. All right, that's it for Unit 3. Good luck. Let me know what I can do to help.